So section 4.5, this is the beginning of the square root review. And so we want to find the value of c. So when we find the value of c, we have c squared equals 6 squared is 36. And then 8 squared is 64. We're going to add our like terms together. We get what? We get 100. We're going to square root both sides because we want to just find one c. So we have c equals the square root of 100 is? No. 10. Okay. So instead of just dividing by 2, we're square rooting it. Thanks for the try, though. So our next one is example 2, and we have c squared. So we have c squared minus 4 squared, which is 16, equals 3 squared, which is 9. We're going to add our like term to the other side, so we can get c squared by itself. We get c squared equals 25. We want to get c by itself. We square root both sides. c equals 5. Beautiful. Okay, our next group is number 3. So number 3, we have c squared minus 10 squared, which is 100, equals 16 squared. 256? 256. We got to add 100 to the other side. We end up with c squared equals 356. We're going to square root both sides. When we square root both sides, we get c equals, is 356 a perfect square?
No clue.
So let's take a second and see if you find it.
No, it's not a square.
So, do you guys agree with Nemo?
Wait.
I will tell you I do. It is not a perfect square. And so we have to use our factor tree. So 2 goes into this how many times?
173.
173. And then factors of 173. Oh, nope. Let's try it again. 170 what? 8. 178. I was like, this isn't working out. Okay, and then we have 178 factors of 178. 2 goes into it how many times?
2. Oh, here.
2 goes into 178 how many times?
89.
89. And what do we know about 89? It is a... It's not a perfect square. It is not numbered, but it's prime. So we have one buddy. The buddy comes out. What doesn't have a buddy stays locked up. We get 2 square root of 89. For number 4, we're now solving for a squared. So we have a squared plus 7 squared, which is 49, and 15 squared, which is
125. No, 225.
225. So 225, we're going to combine like terms. I'm going to subtract 49 over. I get a squared equals 176. We need to figure out if 176 is a perfect square. Nope. So what can we take out of 176? 2. So how many times does 2 go into 176? So 2 goes into 16. 88. Okay, 2 goes into 88. 44. Can you still see that on the gray? Let me change it to a yellow. Well, I hope it doesn't. Can you see it better now?
Yeah. That's fine. I see 2, 4, 4.
Okay, and we're going to continue on. And 44 breaks up to 2 and 22, 2 and 11. Okay, if you have a buddy, you get to make it out alive. So we have 1 pair, 2 pair. 2 times 2 is 4. Doesn't have a buddy.
11.
4 square root of 11. And then now we go on to number 5. We're looking for b squared. 5 squared is
25.
plus b squared equals
144.
144. Subtract 25 over. B squared equals.
No, 119.
Do you guys agree with him?
119.
I do, 119. I write 7 though, 119. And then what are our factors of 119? It is not prime.
It's not prime?
Mm-mm.
It's 13.
Nope. So it means that there's going to be factors. So if you have a calculator, this is a good time. We know it's not going to be even. So 17 is what you think. So how many times does 17 go into it?
I'm just guessing.
Wait, is that 119?
119. So 17 goes into it 7 times. So it's a pretty good guess.
I mean, I knew 17 was there. I just didn't know what.
How many times? So what do we know about 7 and 17? They're both prime, so we can't go any further. So we have b squared equals 119. We have to square root both sides. B equals the square root of 119. Our last one is the square of 5 times the square root of 4. When we do this, we're applying that square to both sides. When we apply it to both sides, we have to do 5 squared, which is, and then we have the square root of 4 squared equals 8 squared, which what is 8 squared? 64 plus b squared. So when we square 4, the square root of 4, what do we get? So you have the square root of 16. The square root of 16 is, it's going to be 4. So those are inverse operations. You have a square and a square root happening. They negate each other. And so you're left with just 25 times 4. So 25 times 4 is what value? It's going to be 100 equals 64 plus b squared. We're going to finish this up by subtracting. And then I hear, yep, it's correct. 36 equals b squared. Square root both sides. B has to equal 6. So for our first one, x, what's the value of x? 52. And so we know this because you have 2 congruent sides, and the angles opposite of 2 congruent sides are congruent. And so the angles opposite of them have to be congruent, so we said that has to be 52 degrees. On number 2, it's the same principle being applied, but we're not looking for that angle. So down here, we see that this angle has to be 20 degrees because angles opposite of congruent sides are congruent. And then we use the fact that we know that the sum of a triangle is 180 degrees. So we have 180 degrees minus 20 to give me that value of x. X equals, yep. So x equals 140. And then we have number 3. It's the converse of it. So now we have congruent angles. The sides opposite of congruent angles are congruent. So L has to be 5.2. And then number 4, we have the Pythagorean Theorem. What is the Pythagorean Theorem?
C squared equals a squared plus b squared.
You guys each took a different start, but you each got there. So we have the c squared is going to be your hypotenuse, or it's the side opposite of the right angle.
I've been trying to remember that word.
Hypotenuse?
Yes, I can't remember.
Okay, so we have a squared, which we know is 24 squared, plus b squared equals 26 squared. 24 squared is what value? 576 plus b squared. And what is 26 squared? 676. You notice this is pretty common for us to use these numbers. And it's because it's super convenient when we subtract over 576. Give me 1 second and I'll be right there. Ooh, we're down low. I'm sorry. I'll move it over here to the side. So we end up with 576 plus b squared equals 676. Subtract over 576. B squared equals, Nemo told us 100. We're going to square root both sides. B equals, yep, Rio, 10. So the top of this page, let's write that distance formula. So we know that it's AB equals the square root of And then it's going to be x2. What comes next? Minus x1 squared plus
y2 minus 1 is 1.
Yep. And that's going to be our distance formula.
I have a question.
So number 5, we have C and we have B. And we're looking for A. Remember that C is going to be the biggest number. It's the hypotenuse, which is directly across from that right angle. So we have 34 squared equals 16 squared plus A squared. What is 34 squared? So we're looking for 34 squared first. 1,156 equals 16 squared. 256. Cam, do you have your hand up?
No, you keep calling on camera.
Oh, I'm sorry. Okay, when we get this, we subtract and we get 900 equals A squared. That is a 900, even if it looks like it has a tail. Let me erase part of it. Oh, well, I erased all of it. Yup. And then we're going to square root both sides. And so as we square root both sides, Ria, what'd you say?
It's 30.
I think it's wrong.
So we get A equals what, Nemo? 30.
You stole my ass the whole time.
Just spoke up. Called on you first. Okay, so our next one is the Pythagorean Theorem again, and now we're looking for C squared, so we don't have to rearrange our formula. So we have C squared equals 14 squared plus 16 squared. 14 squared. Cam?
196.
196. 16 squared? 256. We're going to add those two together. What value do we get? Say it one more time. 452. Okay, is 452 a perfect square?
No.
It's not. So we're going to square root both sides, and then we're going to find out what we can take out. So what goes into 452?
2.
2 does indeed. How many times does 2 go into 452? 226. Okay, let's take a 2 out of that. We get 113. Is 113 divisible by anything, or is it prime? It is prime. So one thing has a buddy, 2 comes out, square root of 113. Our last two problems involve that distance formula. So we're going to find the distance PQ, which equals, and then we have the square root. We need to define which one's going to be our x1 and our y1, x2, y2. So I'm going to just do it in order. So I'm going to have x1, y1, x2. Ooh, that's not where I want that. x2, y2. Okay, and now that I have those, I'm just going to substitute them into my equation. So we know that it's going to be, Ethan, you ready?
No.
So we're just substituting them in. So what's your x2 value? Negative 2 minus quantity squared plus 5 minus 1 quantity squared. We end up with the square root of negative 2 minus 1.
Negative 3.
Negative 3. Negative 3 squared is
9.
9. So two negatives make a positive, so it becomes 9. 5 minus 1 is 4. 4 squared is? Yes. Okay, so Nemo already told us it's going to be the square root of 25, and we know what the square root of 25 is. It's 5. And then the last one is the distance of RS, which equals the square root of. Again, I'm just going to define these as x1, y1, x2, y2. So we have x2 minus x1 squared plus 3 minus negative 1 squared. So this becomes negative 7 squared, which is 49, yes. plus, and then we have 3 minus negative 1. 3 minus negative 1 gives me what value?
4.
Thank you. So that's going to give you 4. 4 squared is 16. So we're going to put that 16 in here. We're going to combine those two. 49 plus 16, 65. When we decide what our factors of 65 are, we can take out a
5 is 13.
13. Can either of those break down any further? Square root of 65. Don't forget that square root. Yes, it does. Okay, so any other questions on this slide? Okay. Our next one is the objective. Once again on these notes, I apologize. I did not leave a spot for the objective. So you're going to add it to the top of your page. And the objective is to use the converse of the Pythagorean theorem to classify triangles. Okay, so the converse of the Pythagorean theorem is if the square of the length of the longest side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then it is a right triangle. So previously we knew if it was a right triangle, then we could use the Pythagorean theorem. And now we see if we can apply the Pythagorean theorem, then it has to be a right triangle. So again, I say that you need at least the symbols and the diagram. So just because it looks like a right triangle, we don't know if it for sure is. And so we have to test it. So we're using that c squared equals a squared plus b squared to see if that's true. So we know c is going to be the longest side. Our longest side is that 13. So we have 13 squared equals, and it doesn't matter which one's a and which one's b because you're adding them together. So we have 12 squared plus 5 squared. 13 squared equals what? $169.
Why are we using the C squared? If ain't no C.
Okay, so then we have 12 squared, which is what? 144. And 5. We're going to add up the left-hand side and the right-hand side. So 169, 144 plus 25 is?
169.
We see, oh, I wrote it backwards. We see that they are equal. And so therefore, remember our symbol for therefore is those dots in a triangle. So we see, therefore, if I can figure it out, there we go, triangle. And this triangle is EFG. EFG is a right triangle. Okay, so we have to try it again with this one. So we see the longest side is going to be C. The longest side here is 10. So c squared, we'll do a squared plus b squared equals c squared. We know that that's going to be 8 squared plus 9 squared equals 10 squared. What's happening? So we have to make sure we're verifying. So we are not judging it based on our looks. We are judging it based on the Pythagorean theorem. So we see here we have to add up 64 plus 81. What is 64? 145. Does 145 equal 100? Oh. I hear you guys say 145. I said 145. I just didn't write it. So we see that these aren't equal. Therefore, triangle. What's my name of my triangle? EGF is not right. So we're applying the exact same thing. So we see that our longest side is going to be c squared. So that's going to be 37 squared equals our 2 legs, which is 35 squared plus 12 squared. Somebody who has a calculator, can you tell me what 37 squared is?
1,369. Did you want to answer?
No, she didn't mean it.
Equals, what is 35 squared, Cam?
1,225.
1,225. And then we have 12 squared, which is 144. We're going to add that right-hand side up. When we add those up, what value do we get? Is that what you get?
Yeah.
So we see that that holds true. So therefore, triangle ABC is right.
So if it's equal, it's true.
If it's equal, it's true. If it's not equal, it's not
That
true.
makes it a lot more easy.
That's what that Converse was telling us.
That makes it
So
a lot
again,
more.
how do we know which thing we're supposed to
We was
use?
talking about earlier, it was
C
hard.
equals or the which how we
So all right now, all you have is C squared equals A squared plus B squared. That's the only formula I've given you for this.
okay.
So that's the one you're using.
Okay.
Oh,
Oh?
Dang.
I was right, no, but I was right.
okay. So now we're gonna solve the next one. So here we see that we have 20 squared equals 17 squared plus 17 squared. So 20 squared is the easy one. I'll take it. 400. 17 squared.
289.
What is it?
289.
289 plus 289. What value do we get when we add those two together? 578. It's not the same. So therefore, triangle ABC, it's not right. Okay. Number 3 is our last step for this one. So we have 30 squared equals 18 squared plus 24 squared. 30 squared is what value? It's 900. What is 18 squared?
2,700.
Don't just guess. 18 squared. 324. 24 squared. 356. 576.